Hello, this is Ms. Howington at Research Triangle High School, and today we are going to talk about the shore ecosystem, or the intertidal zone. Behind me you can see where the sand goes from like really bumpy to nice and smooth and flat. So this is the high tide line here, and it's right about low tide right now, so the water is down at its lowest point down the beach right now, and a little bit later when it's high tide it'll be up here at its highest point. And so in between those 2 points, the high tide and the low tide line, is what we call the intertidal zone. And so you might be asking yourself, why should we study these places? Well, so the intertidal zone, or the shore, is the part of the marine ecosystem that we interact with, I might argue, the most, because this is where a lot of people tend to go and take vacations. It's very easily accessible, so it's a huge source of tourist income. And with the rising sea levels that we're expecting to see, we're a little bit concerned about how this ecosystem is going to change. And also we have a lot of our large cities that are located near shores. With most ecosystems, there are gradients in these ecosystems, so it's not just like one consistent condition. And these different, these changing abiotic factors tend to lead to the creation of zones, or zonation. So in the intertidal zone, we are looking at the different abiotic factors that influence the ecological communities are the amount of time that an area is either wet or dry. So all species in the intertidal zone require some access to water to live and to complete their life cycle. They are marine species, but some of them have different tolerances to being dry or to being wet. And so that will help determine how these animals distribute themselves, or how these plants distribute themselves. And then also in the intertidal zone, you have varying amounts of wave action. So closer down to the low tide line, that area is going to receive a lot more of the impact of waves. So that's going to make it a little bit harder for things to live. So this presents some challenges to organisms, which we'll talk about a little bit later. It's really hard to survive when something is constantly hitting you. Just makes things a little challenging. Also on the shore, we are looking at a gradient of sediment size. So larger sediments, since they have more mass, they tend to stay put in areas, and it tends to take a lot more higher energy water to move them. And so they tend to be a good surface for organisms to colonize. So that's good for epifauna, which is the animals that are sessile. But it's not good for infaunal taxa, which are things that need to burrow down into a sediment. Smaller sediments, since they have less mass, they are easier for the water to wash away. And so they don't tend to be a good surface for organisms to attach to. So this kind of explains why on rocky shores we see things that are attached to the rocks and living there, and then on sandy shores we tend to see a lot more organisms that burrow down into the sand. The gradients that we just talked about, the abiotic factors, they interact to create different zones or patterns of distributions of organisms. It's more obvious in some ecosystems than others. So in rocky shores, it's way more obvious than in sandy shores. And so the causes of this zonation are twofold. So the upper limits of the zone are generally found to be determined by tolerance to stress of certain abiotic factors, and especially the tolerance that juveniles might have, because the juvenile stage is the most vulnerable stage of an organism's life cycle. So a lot of times we're looking at tolerance to exposure or submersion. So if they're exposed, they're at risk for drying out or desiccation. And then if they're submerged, it's easier for them to feed a lot of times. But yeah. And then also the thermal tolerance. When organisms are out of the water, it's going to get a lot hotter. And the lower limits of the zone are typically determined by biotic factors like competition and predation.